All right, hey guys, this lesson is going to go over lesson 10.7, some factoring special products, or some factoring shortcuts that we learned about on Friday. Okay, so as a quick warm-up, can you go ahead and factor all three of these? So we'll pause the video and push play when you have tried them all. All right, so using any method that you wanted, this one's going to factor to be x minus 5 and x plus 5. Maybe use guess and check on this one because I can quickly see that it has to be x squared, 5 and 5, and then to get 0x, one had to be negative, one positive. Okay. B, again, is the kind of the same thing, x minus 3 and x plus 3. And C, when you factor that, no matter how you did it, it's 2x minus 6 and 2x plus 6. Now, once you factored, hopefully, if you wanted to make sure you're right, you just, again, multiply it out. Make sure you double distribute or use another method to make sure that it is correct. Hopefully you noticed something about all three of these because that was kind of our first shortcut that we learned on Friday. So today we're going to kind of go through those two shortcuts. If you notice them, use them. If you don't, then just use one of our other methods. You can factor by grouping. You can factor using box and diamond, or you can factor using guess and check. Okay, so any of those methods will work, but then today I'm going to go over some shortcuts. All right, so our learning intention for today is we are still learning about factoring, and we're going to talk about some shortcuts that you can use when you are factoring. You'll be successful when you can factor a trinomial using those shortcuts, and if you don't notice those shortcuts, you can definitely just use the other methods that we've learned this module. All right, so quick little test of yourself. Can you go ahead and list the first 14 perfect squares? So I'll just give you a second to start listing those. All right, first perfect square is 1, because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, then we got 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and 196. And that is good enough for now. So those are some perfect squares. Again, perfect squares are things that you can take the square root of really nicely. So if I said the square root of 36, you would say 6, because 6 times 6 is 36. This is going to be helpful when we are working with some of the factoring shortcuts that we're going to talk about today. All right, so last week when you were doing board work, the first thing that hopefully you noticed is a little shortcut called the difference of two perfect squares. So written in mathematical terms, it looks like this. It says, hey, if I have a squared minus b squared, a quick way to factor that is a plus b and a minus b. Okay, now this is a shortcut. This only works if you have two perfect squares here. For example, if you have 36x squared minus 25x squared. Those are both perfect squares. Or I can even get rid of the x squared if I just have minus 25. I can use this shortcut to quickly factor it. So first thing I always check for is, hey, are these both perfect squares? Well, 36x squared is a perfect square, and so is 25, and then it is the difference of them. So if I was going to factor it, all I do is I do the square root of this. Square root of 36x squared is 6x, so I put 6x and 6x. Square root of 25 is 5, so it's 5 and 5, and then it's a minus 5 and a plus 5, and the reason for that is because there is no middle term. So if I'm looking at 36x squared and minus 25, it's kind of like I have a plus a 0x here in the middle. Those need to cancel out. So if you guys look at that, the negative 30x and the positive 30x are going to cancel out and leave you with 0x. So this, again, is called the difference of two perfect squares, and you can definitely use this method if you notice it. So let's look at a couple examples. So my first one is x squared minus 36. So first thing I check for is, oh, that's a perfect square. Square root of x squared is just x, and that's a perfect square, and it is the difference. So then I'm going to use my little shortcut. Okay, so the square root of x squared is x, so I'm going to put x times x. Square root of 36 is 6, and then it's plus and minus. Now again, you can always check this to see if you are correct by multiplying it out. So if you did multiply it out, remember I kind of double distribute, so I get x squared minus 6x plus 6x and minus 36. You would notice those cancel, and you end back up with x squared minus 36. All right, so why don't you guys go ahead, try the next 3, pause the video, and when you're ready to check them, just push play. All right, so the first one, again, these are both perfect squares, so you can do the difference of them. So I get the square root of 25x squared is 5x, so I'm going to do 5x and 5x. Square root of 81 is 9, and it's going to be minus and plus. Doesn't matter which order you do that in. So that is factored. Okay, again, this one, I see a perfect square, and the difference. So I'm going to do the square root of 16, which is 4 and 4, square root of x squared, which is x, and then it's just plus and minus. Again, if you wanted to check it, just multiply it out to see that it works. Okay, and then finally, again, perfect square, 9 and k squared are perfect squares. 49 is also a perfect square. Okay, so I'm going to do the square root of 9, which is 3, square root of k squared is k, so 3k and 3k. Square root of 49 is 7, and then it's plus and minus. So you just factored all of those using a little shortcut called the difference of 2 perfect squares. Again, if you didn't notice that, then you can go ahead and do factoring by grouping. You can do the factoring by guessing and checking, or box and diamond. You can use any of the methods that we've learned as long as you get it factored correctly. All right, so go ahead and now try these 4. See if you notice anything about them. So I'm going to give you a couple minutes to try these out, and then again, please push play when you have a chance to try all 4 of them. All right, so if you looked at the first one, hopefully you noticed that, well, that's a square, perfect square, that's a perfect square, but it is not the difference. So if you tried to factor that using that shortcut, and I did minus 3 and plus 3, you're going to notice that you're going to end up with that negative 3 times positive 3 is 9, negative 9. So you would end up with x squared minus 9, and that is not what that says. Okay, if you tried to factor it and be like, oh, is it just x plus 3 times x plus 3 then? Well, if you do that, look at, I get a 3x and a 3x, which is 6x. I would get x squared plus 6x plus 9. Again, that's not what it said. So this one is actually prime. You cannot factor it. Okay, let's look at the second one. Those are both perfect squares and the difference. So square root of 64 is 8, and 8, square root of x squared is x, and then I can have minus and plus, or opposite. It doesn't matter which way. All right, the third one, let's see if anybody noticed this. We've been talking about factoring completely. So when you see a problem, the first thing you should really be checking for every time, and I should have done that on the other ones, but I didn't want to tell you before you tried it, is there anything I can divide out of those first? You always need to see if you can divide something else. Divide something out. So I can divide a 5 out. So I'm going to rewrite this as 5 times x squared minus 18. Okay, now if I look at that, 18 is not a perfect square. X squared is, but 18 is not. So this is as far as I can go. I cannot factor this x squared minus 18. All right, and then the last one, if you look at this one, there's nothing I can factor out of the whole thing, and it's not difference of perfect square, so this is just kind of a review one. When I have 4 terms, I'm always going to try to factor by grouping. Okay, so I've got 4 terms there. Let's try to factor by grouping. So it looks like I can rewrite this with an x squared on the outside, and then x minus 5, okay, plus over here, maybe I'll divide out a negative 100, and then it would be x minus 5, okay? And then, ooh, this is a tricky one. I end up with x minus 5 times x squared minus 100. Okay, this one is super important. So now, hopefully, you should always check inside here. So, like if I go back to here, 8 minus x and 8 plus x, there's nothing else I can do to that. Same thing here, x minus 3, x plus 3, those are good. But if I look inside here, x minus 5, that's good. Ooh, x squared minus 100. I can actually factor that again. I see 2 perfect squares, the difference. So I'm going to keep my first factor, x minus 5, and then I'm going to factor the x squared minus 100. So if I do that, square root of x squared is x and x. Square root of 100 is 10, so plus 10 and minus 10. So I factored it. This one actually has 3 factors, and now that is factored completely. Okay, so please always, always, always make sure you are checking your factors at the end to see, hey, can I factor that even more? Can I break it down even more into some other factors? All right, let's check out the next one. It says Rosita's family is buying carpet for their living room, and their living room is 6 by 6. Okay, so you can see here 6 by 6 meters on the side here. they're going to carpet everything except this little area here. So they're not going to put carpet in this little square, which is x by x. It says, can you find the factors representing the area of the living room that will be carpeted? Okay, so I want to find, well, what is going to be carpeted? So they're going to carpet everything, so that big square, but not that little square. So think about, well, how could I represent that? How am I going to just find the area of this random shape here? That's not really a shape. Okay, so what you could do is you could take the area of that big square and then take away that little square. Okay, so if I do the area of the big square, 6 by 6, that's 36. Then I'm going to get rid of this little chunk, which is x by x, which is x squared. Okay, now it does say, could you find the factors representing the area? Well, can you factor this? Okay, so could you factor that right there? Looks like the difference of two perfect squares. So the square root of 36 is 6. Square root of x squared is x. So it's 6 minus x and 6 plus x. And you just wrote the area as two factors. Or I should say the product of two factors. All right, the next little shortcut that hopefully you learned on Friday looks something like this for factoring perfect square trinomials. We have a trinomial. You guys can see that there are three terms. Something that is special, this is what you kind of want to notice. If you look at the first term and it's a perfect square, that is, and you look at the last term and it's a perfect square, that is, and then if you look in the middle, and you guys found this out on Friday doing your board work, if that is found by taking the square root of the first term, okay, so that's 9, times the square root of the first and the last term, which is just 1x, and then doubling it. So if I double that, I get 18. Then it's a perfect square trinomial. So let me explain that one more time. So if you take the square root of this, which is just 1x, square root of this, which is 9, multiply those, 9x, and then double it, which is 18, then I know this is a perfect square trinomial. So what you can do if you have something like that, I'm just going to write it down here, is a quick, easy way to do it is you can actually take the square root of that, which is x, square root of 81, which is 9. Since it's all plus, it's just going to stay plus. So it should be x plus 9 squared. Okay, now you can always check it because 9 and 9 does make 18. Okay, so you can use this shortcut. Again, you don't have to use it if you don't notice it. If you do notice it, definitely use it. So here's a way that you can try to kind of go through in your head when you're seeing something like this. So first thing I always just kind of see is like, ooh, that's a perfect square. Ooh, that's a perfect square. Okay, if I square root this, it's x, 25, which is 5, and then double that is definitely 10. Okay, so now I can go ahead and factor it. So if I factor it, it's x and x. It's 5 and 5 for 25, and then it's all plus. So it's x plus 5 times x plus 5, which another way to write that is x plus 5 squared. So that is a perfect trinomial, or a perfect square trinomial. So let's look at the next one. Okay, 4x squared, that is a perfect square, right? Square root is 2x. 16, perfect square, which is 4. Okay, so that's good. Now, let's multiply those. So 2x times 4 is 8x. The middle has to be doubled. The middle is not doubled. Okay, so I cannot factor it using that shortcut. It would not work. Now, if I tried, let me just see if I tried. If I tried 2x and 2x and 4 and 4, and I'd probably make it minus. Okay, let's see what happens. Well, I get negative 4 times negative 4 is 16. That's good. 2x times 2x is that. But then if I do the negative 4 times the 2x, I get negative 8x, and I get another negative 8x, which is not that. So then I would need to try to factor it a different way, which we're not actually going to factor right now, but then I would need to factor it using one of my other methods. Okay, let's check the next one. 9x squared and 25. Those are both perfect squares. Okay, square root of that is 5. Square root of that is 3x. Multiply, I get 15. Double, I get 30. Okay, so I can use my little shortcut to factor it. Okay, so I get 3x and 3x. Okay, 5 and 5. It's all pluses, so it's going to be plus. So 3x plus 5 squared. Again, if you don't notice that, just use one of our other methods. But I would always just even test that out. And then if it doesn't work, then I'd go to like factor by grouping or box and diamond or guess and check in my head. So those are some methods you can use. All right, let's check out some of these examples. I'm going to do a couple together with you, and then I'm going to have you try the rest of them. So let's go to this one first. Okay, so this is just kind of putting everything together. So if you look at that one, right away I noticed like, ooh, there's kind of a lot of M's, and they're all even numbers. So before I can even try any tricks, I need to go ahead and see, is there a common factor I can divide out? Well, it looks like 2 goes into all of them, and there's an M. So let's rewrite it. 2M parentheses. Okay, it'd be 4M squared minus 12M plus 9. Okay, now if I take a look at that, do you notice anything? Ooh, perfect square, perfect square. So let's try 2M. Okay, well, square root of that is 3. Square root of that is 2. 2 times 3 is 6. 6 doubled is 12. Ooh, so that's good. So let's try our trick. So the square root of 4M squared is 2M and 2M. Square root of 9 is 3 and 3. Now here's where you just have to be careful. You see a positive answer here, but a negative answer here. So I got to have negative somewhere. In order to make it a positive, I'm going to have a negative times a negative, which will give me a positive 9. But then here I get my negative 12M's. Okay, so it looks like my final answer, I can kind of keep it like this. 2M parentheses. I can do 2M minus 3 times itself twice, or I could just put it squared. Okay, again, always just kind of look inside here then and be like, ooh, can I factor that any further? I can't. Okay, and the 2M on the outside is fine. Please don't forget that. So there is my final factored answer. All right, let's try one more. Let's try the one right next to it. Okay, so first thing I notice is, ooh, those are perfect squares. So let's try that. Okay, so if I try those out, let's do, I have 6x and 6x and 5 and 5. And then remember, it's got to make a 60. Well, if I have a 30 and a 30, that's definitely going to make a 60. Okay, now you just need to figure out the signs. Okay, if I look, I have plus and minus, so I'm going to try minus and minus, because when I multiply a negative times a negative, that gives me a positive. So it is 6x minus 5 squared. Now, again, always look inside here. I look inside and I see, hey, those don't have a common factor, so I can't do anything else to it. So that is my final solution. So I'd like you to try the other problems that are remaining. When you are done, you can check the answer key that I left. And then there are some more problems for you to practice for the rest of the hour. If you get stuck on one, please ask one of your classmates and hopefully they can help you figure it out. Otherwise, you can ask Mr. G tomorrow because he will be subbing for me again as I am gone the rest of the week.